G'day guys, Socket here. In today's tutorial I'm going to take you step by step through how to do a car audio tune using the new Audio Tech Fisher's Tune to Target software tool. Now you can find this tool in the new version or the current version of the Audio Tech Fisher DSP PC tool software, which is version 6. Now the Tune to Target tool is not really an end-to-end car audio tuning tool or suite. It requires you to do a few things like time alignment and crossover setting and stuff like that before you can use the tool itself. Now, if you've already done that, then you can skip a lot of this tutorial and just jump straight to the Tune to Target piece. I'll give you the timestamp above here, tell you where that starts in the tutorial. But if you're not too sure how to do all of that stuff, then don't worry, I'm going to show you how to do that. So watch the tutorial from the very beginning. Alright, with all of that said, let's head out to the garage and get on with today's topic. Okay, so here we are out in the car. I've got my laptop ready to go. I've plugged in my USB U-mic microphone ready to do the measurements. I've got my DSP connected to my laptop via the USB cable, and I've got my phone with the test tracks loaded onto it, so I'm ready to do some measurements. So of course today we're going to do the end-to-end tune demonstration using the Tune to Target tool in the Audio Tech Fisher DSP PC tool software. Now if you haven't already upgraded your software to version 6, you'll need to do that first, because the Tune to Target tool is only available in version 6 and only available on certain models of the Audio Tech Fisher DSPs, right? Yeah. So if you haven't already upgraded it and you're not too sure how to do that, I have a standalone tutorial that explains all of that. I'll leave the link down in the comments below. So we're ready to fire everything up, so make sure that you've got your DSP connected via your USB cable, and yeah, and then we can kind of launch it and take a second just to load up. Alright, so okay, the first thing we need to do before we can connect up is, if you don't already have your test track files, you can find them under this little icon here, and we're going to need 3 files. They are under Tune to Target. Now there's a WAV file and a FLAC file, so it depends on which file your source unit can play. I'm just going to use the WAV files, so I'm going to use the 44.1 uncorrelated pink noise. I need to grab that. I also need, under the real-time analyzer folder, the correlated pink noise file, so I need that 44.1 WAV file from there as well. And the last file is the automatic time click. It's this second one here, 44.1 bit WAV file. So grab that as well, and then transfer them onto your phone or whatever device you're going to use to play those test tracks through your speakers. Okay, with that all done, I think we're ready to go. So I'm going to hit connect and let's get started. Okay, so we're just going to connect up, and first of all I'm just going to show you the Tune to Target tool and talk a little bit about it, and then I'm going to come back and explain how to set everything up. So the Tune to Target tool is here under the RTA tab. You just click on that, and then it should open by default. You can find it down here in the bottom right hand corner, but if for some reason it doesn't, then you just click on this little automation tab, this little 1 out of 4, right? And then you'll find it down here. So you click on that, and this will bring you to the Tune to Target homepage. Now I've got to say that the Tune to Target tool is not a full end-to-end tuning tool. There are things that you need to do before you can use the tool itself, and those things are listed here. They include setting up the DSP in terms of inputs and outputs and naming your speakers and doing all that type of thing, making sure that your speaker polarities are correct, making sure your measurement microphone is set up and receiving a signal at the correct level, putting in your crossovers for your speakers, and making sure your speakers are all time aligned. So it's, yeah, as I said, it's not an end-to-end tuning tool. It kind of picks up the piece where it starts to do EQ and level matching and stuff like that. That's really the part of the tune that it's automating, right? So if you are just beginning and you're not familiar with how to do time alignment and things like that, don't worry. I'm going to run through how to do all of these 5 things in this demonstration. If you're a little more advanced, then you want to skip over all of that stuff, all of the setup stuff. You can just go down to the automatic chapters in the description, and you can just click on the tune to target piece of the demonstration and skip right ahead. But all that said, I think the Audio Tech Fisher guys have done a fabulous job with this tool. They've provided a lot of instructions on how to use it, and they've even provided an easy tuning and an advanced tuning mode, depending on your level of skill. Now, in today's tutorial, I'm going to be using the advanced tuning mode. Yeah, so we're going to come back to this screen in a little bit. What I want to do is just jump back to the DSP homepage and have a little bit of a talk about how you might set things up before you start doing the tune. Okay, before we go on, I just want to explain that there's 2 different ways that you could approach using the tune to target tool. So one way is to just start with a completely fresh tune, which is what I'm going to do in today's demonstration. And the other way is to use the tune to target tool on an existing tune. If you want the system to, for example, re-EQ all your speakers and re-level match everything. So, for example, if you were doing an existing tune, and let's say I'm just using this one as a demonstration, you want to keep your crossovers and you want to keep your time alignment, but you basically want to reset everything else. That's your channel gains and your EQ work. Now, you can do that pretty much manually by just hitting reset down here to reset the EQ back to 0, and you can change your channel gains here. It's at 1 dB. I'm just going to bring it back to 0 dB. You can do it manually like that. Remembering you want to keep your delays and things, so don't touch those, and your crossovers, don't touch those. With your crossovers, yes, you do need to convert them all to Linkwitz-Riley 24 dB slopes to use the tune to target tool. So if you have any that are not Linkwitz-Riley, I think these are bezels, so I need to switch those to Linkwitz, like that. And this one, yeah, it's bezel as well. Okay, so just reset, but you can keep your frequencies. You just need to make sure that they match on the left and right side. So 200, 3000, 200, 3000 is fine. 3000 to 20, 3000 to 20, they're fine as well. And just check all your other speakers. Now, a quicker way of doing all of that is just to go up here and click and go reset output equalizer and reset channel gain. And you can leave your crossover settings and your time and phase alignment, so that's all fine. And just hit OK. And yeah, that will get rid of any gains and get rid of any EQ work. It won't change your filters to Linkwitz-Riley 24 dBs. You'll need to do that kind of manually. So that's if you are doing a tune to target with an existing tune. But as I said, today I'm going to work from a brand new fresh tune, start from the very beginning. So that means we need to basically get rid of everything, and the easiest way to do that is no output equalizer, no high pass or low pass, no channel gains, no time or phase alignment, or any of these things on the virtual channels. I can leave the input equalizers and things. I don't want to reset my DSP or sound effects or things like that. Or my input-output configurations. I'll show you how to set those up in a minute. So yeah, we can just click that, and that should take care of pretty much everything. And you'll see that there's still crossovers in because the DSP has reset everything to default. Okay, so that gives us a kind of a fresh start. And so let's pop over and take a closer look at the things that we need to do to get this tuned to a point where we're able to use the tune to target tool. Okay, so let's have a talk about the things that we need to do before you can start using the tune to target. And the first one of those is the routing and source configuration has to be verified, and all channels must be named correctly to match your speaker setup. So what are they talking about here, Socket? Well, it's all to do with setting up the DSP to match the configuration of your unique car audio system. That is, what sources are you using to play audio signals and connect to the DSP? What virtual channels are you going to set up in the DSP? And what speakers are you connecting to the DSP's output, and then naming those speakers in a standardized way, because I think the Tune to Target tool must use those speaker names when it comes to setting crossovers and stuff like that. So we're going to have I'm going to walk you through how you do all that now, and the menu that we need to go to is the input-output menu. Now, to find that, it's here under Signal Management I/O, where I/O stands for inputs and outputs. Now, I'm not going to go into a huge amount of detail about this particular screen or what virtual channels are. I have some standalone tutorials on the details of how this particular screen works, and how virtual channels work and all of that stuff. If you need more detail, I'll leave the links to those tutorials down below. But very quickly, this is basically the inputs to your system, and over here on the left hand side, in the middle is, or over here on the right hand side, is your virtual channels. And if we click this one, which is virtual to output, we have the virtual channels now on the left and your outputs on the right. Okay, so let's just start with the inputs. So there are three different types of source units or inputs that you could connect to the DSP. They include analog inputs, which is under the heading main, Bluetooth inputs, which are under the heading HELIX extension card or auxiliary, and digital inputs, so optical or coax cables from your head unit or a digital player or something like that. Now you'll notice that these three inputs, this has a lot more options than the Bluetooth or digital. So Bluetooth and digital just have a left and right input channel, so just left and right channels, I should say. But the head unit, which is usually your analog unit or main unit, will have the left and right, but it might also have rear output channels or a center output channel or something like that. Now, I personally don't bother with any of those. I just always use left and right. But if you want to use a rear output channel from your head unit, then absolutely fine. So you need to tell the DSP how you intend to connect, which source or which input signal you're going to use, and you can only play one at a time. You can switch between them. But if you're going to use one or more, then you need to configure them here in this input-output tab. So let's say that we're going to do all three, right? I'm going to have a head unit connected. I want to be able to play my phone, and I've got an optical cable that I plug my phone into sometimes if I want to use digital instead of Bluetooth, right? So I'm going to have to set the configuration up for each of these different sources. So And so we have three tabs here. It's main, Bluetooth, and digital. They all need to be set up. That's the inputs. I will come back to them in a moment just to show you how to set them up. But first of all, I want to explain virtual channels and output channels. And I'm going to start with output channels. So we'll go and do that next. Okay, your output channels are found here on this tab, virtual to output, and they're over here on the right in this bluey grey colour. So I'm running a HELIX Ultra, and so that's got 12 output channels. Now you might have a different model DSP, and it might have 8 channels or 10 channels or 6 channels or something. So it will certainly look different to my setup. And then I have my speakers, right, connected to each of these output channels. So this car has a 3-way front stage, so tweeters, mid-range and mid-bass. Then it has rear speakers, so a left and right rear speaker, and then it has a front sub and a rear sub. And they're all connected to the outputs. Now, on the when I say outputs, on the back of your DSP will be where you connect your speaker wires, and they'll be connected to output A or B or C or D. So this is where we tell the DSP what speaker is connected to which output. Now, normally you just do them from high to low. So I've got my left and right tweeter, my left and right mid, my left and right mid bass, my left and right rear, and then I've got my my rear subwoofer on channels I and J, and my front subwoofer on channels K and L. So, you know, from high to low. Now, you can change the name of your speakers, and in fact, one of the requirements in the Tune to Target tool is to have your speakers properly named. So, for example, if this is a tweeter, but I've given it a mid-bass name like that, then it's going to it could cause errors in the Tune to Target, because I think Tune to Target uses this name when it comes to sense checking whether the crossovers and things are correct. I'm not sure, but just a bit of an educated guess, as I said before. So you want to use the right naming conventions for your speakers. So when you look at them, you have these terms such as high, mid, and low. That usually stands for tweeter, mid-range, and mid-bass. Sometimes you'll see the word full, you know, so that might be a center channel, right? But let's have a look at a few of those. So usually your front stage will be, you know, front, high, mid, and low. You might have rear speakers. They could be rear tweeters, they could be rear mid-range, they could be rear mid-bass, right? Or they could be a coax speaker, so you might put them down as full, right? You have your different subwoofers, you know, 1, 2, 3, 4. Maybe you got a pair of 12s at the back, so you might want to call them left and right. Yeah, there's lots of ways to name the speakers, but you want to sort of make sure you name them with something that represents your speaker, but don't stress too much, right? Okay, so that's outputs, and next I want to show you virtual channels. Okay, so I'm going to go back to the inputs screen. So as I said, there's main, Bluetooth, and digital. They're all the same. Well, they're all the same in terms of the virtual channels. So let me explain. So virtual channel, well, in version 5 of the software, you had the choice of either using virtual channels or turning them off. You don't have that option in version 6. They're on by default. So what is a virtual channel? It's basically, well, as your signal comes into the DSP as an input signal, and then leaves the DSP as an output signal, you have these virtual channels that kind of sit in the middle. And what they allow you to do is combine and mix and match different input signals and route them to any speaker that you want to. So let me give you an example. Let's say I have my rear speakers and I want to run them in differential refill. That means I can take a left channel and a right channel and flip the polarity on my right channel and create a virtual channel called rear left. I can do the same but reversed or mirror imaged to create a channel called rear right. And then I can take those rear left and rear right channels and attach them to my rear speakers, right? Rear left, rear right. Now, I couldn't really do that without having the ability to create virtual channels, because there is no input that gives me a differential like this, right? It's a channel that I can make up using, these combination of stuff, and the same with my subwoofers, right? I'm able to create a virtual channel using half a left and half a right to create sort of a mono signal to go to my subwoofer. And I might do the same on my second subwoofer. In fact, I have, but I might want it to be 40% left and 60% right. I can do weird combinations and create a channel that I can then match with, whoops, not this one, routing. I want to go back to the top. There we go. So I want to use those subwoofer channels, and I can match them or link them to my output, my subwoofers, right? One subwoofer 1, subwoofer 2, and blah blah blah, right? Okay, so that's what virtual channels are used for, right? Now I need to create a virtual channel to connect my my front stage, so my tweeters, my mids, and my mid bass. And in this case, I just want to use a left and a right. I mean, I don't want anything fancy with a blend of staff or something, right? I just want left and right. So in this case, I just attached left and create a virtual channel called left front, and a right virtual channel right front. And there's a pull down menu. You can create all different types of virtual channels, give them different labels, right? Now there's a bunch of them I haven't used down here. Now maybe I would want to make a center fill, right? And I might want to drag, a left and a right to create a new center fill channel if I had a center channel, right? But I'd right click to get rid of them. So yeah, so I now have 6 virtual channels set up. One which is just a left, one which is just a right channel, a couple of differential rear fills, and a couple of subwoofer channels, right? And happy days. Now that's set up for the main. I need to do the same for the Bluetooth. So that's just dragging your left, right for your Bluetooth and my subs. And I'm doing the same for my digital signal, right? Now if you're not using digital signal, just right click them, get rid of them all, you don't need it. Or if you're not using Bluetooth, get rid of them all, you don't need them. But in this case I'm setting up all 3 channels, right? Because I do have Bluetooth, I do have a head unit, and I do have a digital converter card which I use for a DAP player once in a while. So I've set up all 3. Great. Don't need to worry about this digital output routing. I just leave it at default. And now you should have the appropriate virtual channel linked to each of your speakers, right? Okay. So one last thing, going back to here. If you do have your speakers set up in differential, your rear fills, you'll need to turn them off, because the tune to target won't work with differential refill settings. So I need to get rid of my right one and my left one, and yeah, same over here, right? Just set them back to normal, not differential, and it should work just fine. All right, so that is how you set up your input outputs, and also make sure that your speakers are properly named. So if we go back to the tune to target list that you can see here, we now have the the routing and source configuration is all set up, and we have all of our channels named correctly and matching your speaker setup. So now we can move on to the second one, which is setting crossovers. Now the requirement for this is you have crossovers for all of your speakers, that they match, so the left and right frequencies or crossover frequencies are the same, and you must use Linkworth-Riley 24 dB slopes. So let's go and look at how you do that now. Alright, so we're going to go on to setting crossovers for our speakers. Now, you don't need to use this software to do your crossover setting. You can use REW, you can use Open Sound Meter, or any other tool that you're comfortable with. But I'm going to show you how to use the version 6 software using the RTA tool to measure the response of your speakers and work out where your crossovers should be, right? So first of all, to do that, we need to set up all of our speakers so we're doing what we call full range measures. That means no crossovers, no EQ work, nothing like that. Just raw, natural, naked speaker responses, right? So we're going to work from the tweeters all the way down to the subwoofers, and we're going to get rid of any crossovers. So if we look at the tweeters, we have the high pass filter, which allows the speaker to play anything that's higher than the crossover, and the low pass filter, which allows the speaker to play anything lower than the crossover, right? So first of all, we do need a 1000 Hertz crossover, 1000 Hertz crossover, to protect the tweeter from low frequency damage, right? Tweeters have very small excursion, and if you get them to play low frequencies, it requires the speaker membrane in the tweeter to move in and out much further than it normally would, and that's how tweeters get damaged. So we don't want it to play a low frequency, so we put in 1000 Hertz just to keep it nice and safe. But outside of that, we want a 24 Linkworth-Riley 24 dB slope. You change the the slope or type of slope like this, and so set it to 24 dB Linkworth-Riley, and then on the low pass filter, which is this end, we want to go beyond 20,000, right, or 20,000 up. So we can do that a couple of ways. We can either just pop in 20,000, and now 24 dB, or we can hit bypass, right, or we can turn the slope off, right, and just make it flat. So I personally like to, I mean, we don't really need a slope on the tweeter at this end. I just usually click bypass and just leave it off for the moment. And so we do that on both the left and right. So we need 1000 on this one. That's already Linkworth's 25, and I'm going to bypass that. I'll change that one to 20 just for fun. Right. Apply new. There we go. Bypass. Okay, so now we get into the mid-range. Now we want that to be 24 dB slopes on both of them, which they are, and we can go, well, actually the quickest way to do it is just go bypass like that. It'll come up with a little question. Yes, I do want to bypass it, thank you. And now you'll see the whole frequency range is flat. Right, it's going to measure the whole speaker from 20,000 to 20 Hertz to 20,000 Hertz. So we just do that same for the mids. Bypass the right mid, that's done. Now the mid bass, same. Let's just bypass them. And the right mid bass, that's all done. I'm just checking these crossover slopes are correct as we go along. So far they look fine. Now my rear fills, They're not tweeters. If you have any rear fills or tweeters in them, then you're going to need this 1000 hertz crossover to keep it safe. I don't. These are just wideband, so they're fine. So I'm going to put bypasses on both of my rears like this. Measure them all in full range. Then we have the subwoofers. Now I've got the subwoofer linked because this is one speaker on 2 channels. The way you do that is, just with one highlighted, click again, and it'll link them together. That's why I have 2 little orange dots. And the same thing, we can just bypass that. And the subwoofer, second subwoofer, bypassed as well. Alright, so now we have all of our speakers playing in full range except the tweeters that are capped at 1000. Alright, so now we're ready to basically take some measurements. Okay, so we've got our source unit with the pink noise ready to play. The last thing we need to do is just check that our microphone our USB microphone is properly selected. So we'll go into this DSP configuration tab and then into this sub menu, which is audio input, and just check that you've got your USB microphone selected. So these high definition audio devices are my laptop microphones, and this one is my measurement microphone, the UMic 1. Now you can use either left or right channel, doesn't really matter. And if you've got a calibration file, feel free to load it up. If you don't, that's no big deal. Don't worry too much about it. And then I just select the line input is also my UMic. I'm not sure what these ones are down the bottom. And yeah, we're kind of good to go. So we're now going to move over to the RTA window. And we're not so worried about the reference curves or the house curves and stuff like that, because we're just taking some full range measures. So what we're going to do is play the pink noise. We're going to wave the microphone around the head around your head area to take the measurement. And of course we're going to start with the left tweeter. So we want to go over to this tab here and just make sure the left tweeter is selected and everything else is muted. And that back in the outputs that you've actually got the left tweeter selected. So go here. So you just want to make sure that's highlighted. Now, not so important when we're doing this piece of work, but later when we're doing EQ work, the tool will dump the EQ readings and stuff and timing, gain sets and stuff like that into the channel that you have selected. So it's always a good habit to just select the channel that you're working on, even if it doesn't matter, like we are at the moment. So left high. So the first thing we just want to do is start the analyzer, and you will see a little red line jumping around. That's the analyzer reading my voice. And this green line up the top, so you'll start with when you play your pink noise, you're going to start with your volume quite low, maybe raise it up to about 50%, and then on your phone or your head unit, and then keep raising the level until this bar turns green, and it's kind of in the area that it's in at the moment, and that means that the signal is loud enough. Okay, so we've got the analyzer running. I'm going to start the pink noise now. You'll hear it coming out of the left tweeter. And now we're going to hit the button Start Measurement and start waving the microphone. And you'll see the counting down from 20. When it reaches 0, that means the measurement is done. So we're just going to check the levels now. We want to see whether the levels are high enough. We kind of want it up around this 0 dB level, right? So here we go. It's going to ask whether this is the speaker I want to do the work on. And left high, yes it is. So here we go. And I can kind of stop because I can see that the measurement is a little bit low. I kind of want it to be up a little bit. So we're going to use this third tab. Oh no, we're not. Sorry, ignore that. We're going to turn up the volume on the microphone, on the head unit. So I've got mine at about 3/4 now. You can see the red line is a little bit higher. So let's start the measurement again. There we go. It's a lot higher now. That's better. Alright. Good. So let's give that a go. Just waving the mic back and forward until the counter runs out. And we are done. So we can turn off the pink noise now, and that is the measurement of our left tweeter. So all we're doing at this stage is just checking out where the speaker starts to roll off. And so if you've watched the video on frequency ranges and speaker limits, this will make a little more sense. So we're looking for the lower frequency limit of the tweeter, the point where it really struggles to start playing low frequencies, and therefore the volume starts to roll off. Right. Here's the high frequency limit. It's about 14,500. We can kind of ignore that for this crossover setting, but that's about as high as it's going to play. Then it falls off. And then how low is it going to play? Well, it stays pretty level all the way through, here, and it starts to roll down. So this roll off is probably around about 3000 Hertz. Now, when you're setting crossovers for tweeters, you've got to be a little bit careful not to set them too low. Each tweeter has what we call a resonant frequency. You can look it up in the specs. The shorthand for that is FS. And the FS of the speaker for this particular speaker is 1500, which means I want to set it at least 2 times the FS to be nice and safe. So my minimum would be about 3000. That's roughly where my, the thing starts sloping off. I think I'm going to set my crossover here at 3200, just to give it a little bit of extra safety measure. Alright, so that's the left tweeter. Now we're going to measure the right tweeter and just check that the crossover is roughly in the same spot. So we're going to go over to here, mute the left, unmute the right. Now, as I said, it's a good idea to get into the habit of selecting the tweeter that speaker that you're working on. So now we have that selected, and you'll notice there's a little orange icon up here telling me that it's selected. Alright, so we're just going to repeat the process. The analyzer's already running. We're going to start the pink noise and start the measurement again, and just wait until the countdown's done. Okay, that's done, and now we have the right hand tweeter as well. So once again, it's rolling off about 13,000. At this end, it's kind of rolling off about the 3,000 mark. So setting it at 3,200 to keep it nice and safe is, it's going to work just fine. So that means we now have the crossover measures for our tweeters, and so we can go into the outputs tab and change this crossover to 3,200, leave this one at 20,000 and make this one 3,200, and there you go, we've got our tweeter crossover set. Now we can turn the bypass off that one. Alright, and the bypass off that one, because we've got the slope turned off, so it's going to be a nice straight line. And so, that's our tweeters done, and now we'll move on and do the mid-range. Okay, well, we start by selecting the left mid-range. I'm going to mute the right tweeter, unmute the left mid, and then we can go back into the RTA. Now, we don't, you want the measurement level so we can see it. We're not so worried about level matching and all of that type of stuff and keeping everything equal, because we're just looking at the shape. speaker, but we don't want the signal to creep too far up into the red, right? So we still want to maintain it green. So I'm just going to have a listen to the level and just make sure our measurement level is right. And straight away, that's too loud because it's turning the measurement level up here red. So because the mids have a lot more energy than the tweeters, of course. So just going to play that again. And I'm going to reduce the head unit volume. Okay, so that's a little bit over half. And you can see when I'm not talking, it stays green. Excellent. Now you can see the measurement level is way down here. I can't really see it. So what I'm going to do is use this little offset controller here to slide it up. Now we can see it a bit better. Alright, I think we're ready to go. So let's go and take a measurement. Start measure. Left mid, yes. So I'm just waving the mic, waiting for the countdown to reach 0. And there we go, we've got the measurement of the left mid-range. Now, this is pretty typical of my left mid-range. It, for some reason, doesn't fall off. I'm not sure why it comes up like this RTA, but it certainly rolls off. But yeah, over here on the high side, it's rolling off about 3,300. You can see it kind of does that. There's a big dip. There's a big cancellation here in the middle, which has got something to do with my tweeter pods and the windscreen reflections and things. It's always there. And so I'm not sure what I'm going to set for this. I think what I'll do is measure the left mid-range and see what that's like. But I can certainly set this one at about 3,200, which is the same as we did for the tweeters. So let's do the right mid and see how they stack up. So mute the left mid, unmute the right mid, select the right mid, go back into the RTA. Now the levels should be okay. So I'm just going to start the pink noise. Yep, that's in the green, so that's fine. And I'm going to start the measurement now. Just checking which speaker. Yes, that's correct. There we go. So we can stop that. Here's the measurement here. So starting to roll off, around about 3,300. So 3,200 will be fine. On this side, once again, it's holding up pretty well all the way through there. I'm not going to put the crossover way down here at 100. I think the FS of this speaker is about 105. So I'm going to choose, once again, there's a big dip here to do with my tweeter pods, and there's something there. I kind of want to cut under that if I can, down through here somehow. So I think that just looking at this, that's a big peak. It starts to kind of roll off like that. So it's going to be around about the 230 mark. So I think that's what I'll do, 230 on both speakers and 3,200 on both speakers. So let's go plug that in. So left mid, undo the bypass to start with. And that will be 230 and 3,200. Just happens to be the same as the tweeters, doesn't have to be. But these two speakers the left and right mid-range do need to be the same. So 230 and 3200. Fabulous. Okay, so that's our mid-ranges done. Next, time to move on to the mid-bass. So we'll select the left mid-bass, mute the right mid, unmute the left mid-bass, go into the RTA. Now once again, we're just going to check the levels, just watching this green bar and whether it's creeping into the red. So let's try that. That seems to be okay, so that level's just fine. So let's stop that for the minute. And let's just start the measurement. Here we go. So start the pink noise, get the mic ready, and start waving. Whoops. Yes, that's the right speaker, thank you. So waving. Okay, that's that measurement taken. Now you might be wondering, how come this grey area is not matching up with your speaker socket? And the short answer is this is based on the default crossovers that we already have in the system. As I said, we're not worried about this right now because we're not doing EQ work, we're just checking our crossovers and looking at how our speakers respond in full range. So what's happening here with these mid-bass? Well, you know, it looks like it's playing up to about 180 and then falls off a cliff, and then on this side, you know, it's hard to say, probably 50, maybe 60, and starts to roll off. You know, 50. I'll put in 55. But before we do that, we'll have a look at the other side. So at the moment, 55 and 170. 55, 170. Okay. Let's do the other one. The right hand mid bass. Okay. So once again, the level should be fine. We can just go straight in and do a measure. So start measurement. Oops. Better start the pink noise first. Alright, here we go. Pink noise. Yes. Okay. So that's enough. Time's counted down. Alright, so what do we got? So this is a big peak. It's a little hard to see. It's hard to really tell where that's rolling off, whether it's sort of rolling off here and sort of doing that. Excuse me. But yeah, look, I could probably live with 55 that we had before. Maybe 170 is a bit too high for this one. I might cut it back to, I think the other one was 220. So they're going to be hard to integrate if we have the crossover way back here somewhere, right? So I don't really want to push it too far this way because, you know, that's looking like it's sloping away quite aggressively. So I'm going to go with 55 and 170 for this as well. It's not as clean as the other measure, but it's a bit of it's not an exact science, right? All right, so let's pop those numbers in. We've got 55 hertz. First of all, let's take the bypasses out. 55 and 170. And on the other one, we've got 55, 170. Great. Alright, so just have a quick look at that versus the mids. Alright, so yeah, they'll cross over at nearly 200, so that's okay, not too far apart. Alright, so that's the mid bass done. Now we'll do the rear fills. So we'll turn that off. Select the rear fills. Now I think these are going to be pretty messy. Not sure, we'll soon find out. Okay, so back into the RTA. We're going to play the pink noise. Oh, hang on, before we do that, we better check that we've actually got the right speaker select. We do. Excellent. Alright, so pink noise. And that is pretty low. I can hear it in the background. So I'm going to turn that up a little bit. Alright, and let's just do a measurement. Got my microphone ready. Great. So these are wide bands. They're playing all the way up to about 16,000, something like that. And then down here, they're sort of falling off. You know, this is a big peak. So kind of running through here and then there, whoop. So, you know, maybe 350 might be a good place to cross them. The thing with rear fills is you probably don't want them playing much lower than about 300 anyway. So 350 feels about right. So let's just check the other speaker, the right one. So we'll turn that one off and this one on, and just do a very quick measure. So put on the pink noise, and let's give that a go. Alright, excellent. So pretty much the same big peaky peak going on around 400, 500, 600. But once again, you know, it's kind of getting to 360, 370 odd and then rolling off. So maybe 370 just to keep it safe. There's quite a big dip going on there. So I'm going to put 370s on the rears. So let's go do that now. So take off the bypasses, and that'll be 370, and we can leave the top end at 20,000. We've got the slope turned off anyway, so nice and straight. And we'll do the same on the left. So 370. Oops, I'm going to take the bypass off first, and 20,000. Great. So the low, left rear, right rear, they all match. Excellent. Time to move on to the subwoofers. Okay, so we're going to start with the rear subwoofer first. This is on 2 channels, so it'll light up both of them, which is fine. Now, once again, we just want to make sure that we have everything muted except for the subwoofer. And we go into the RTA and just double check it. That looks fine. And so we're going to check the levels. Now the subwoofer is going to have a lot of energy, so I'm actually going to turn it down a bit. You know, we want to make sure this level meter is not clipping, as they say. So here we go, pink noise on the rear subwoofer. Hey, okay. Turn that down. Alright, so even at 1 bar on the volume on my head unit, that is pretty much clipping. So yeah, so much energy from the subwoofer. I have to bump it up. I'm going to have to go with something like that. You can see the red line over here is just in screen. Actually, just bring it down a fraction. Once again, we're looking for the shape, and it's probably just clipping at 2 bars on my head unit. But anyway, as I said, the sub's got lots of energy. All right, so let's do a measurement, even though it is in the red. Okay, let's go. Start measurement. Okay, that's it. So we're not worried about this end. We'll let it sort of, like the tweeter, we'll let it go all the way as far as it can go. What we're looking for is where it's going to roll off at this top end. So this is a big peak. Probably going to EQ it down like that. So I'm probably going to want to cross over around about 60 hertz, which is pretty close to what the mid bass we're crossing at 55. Well, 65, I can't remember what we put there now. But okay, let's pick 60 hertz. That's for the rear sub. So take out the bypass, and we put in 60 hertz on that. And that's compared to 55. So there, a little bit of crossover. Maybe it'd be more sensible to just make this 55. There we go. All right, so now they kind of match the mid bass. I mean, they don't have to, but it's just nice and neater, I guess. All right, so let's move on to the front subwoofer. So we mute the rears, put on the front. Let's just jump in, just go do a measure. I think the levels are going to be very similar, I imagine. So playing the pink noise. Note the front subwoofer is turned down a bit, so I'm going to raise the volume. Oops, too much. There we go. And start a measurement. Yep, front subwoofer, thank you. Okay. Now I want my front subwoofer to kind of blend with my rear subwoofer. In fact, they're playing most of the same frequency. So I'm, it's kind of, it's hard to say. This is once again a big peak, so maybe it's playing, lower than that. In terms of rolling off, it's probably rolling off at about the 80 mark, maybe a bit higher. It's going like that. So, this is a pretty peaky peak thing, or maybe it's rolling off a bit like this. So it's really hard to tell. But yeah, maybe, okay, I'm going to put my front subwoofer crossover in at 80 hertz. And, do I want 3 crossovers at the same point? That probably not great, but yeah, you don't normally want to have all your speakers sort of on the same crossover zone. So I'm not sure how low this front subwoofer is going to play, but I want to stay away from that 55. So yeah, hard call. I'm not sure whether this is just a peak and this is running flat like that, or whether this is, doing something like this, right? And it's that's really not there at 30. But you know what? I'm going to have a little go at this, and I'm going to cross this one at 40 Hertz. So 80 and 40, it's very narrow, but hey, you only live once, right? So turn the bypasses off. I'm going to make that 40, and this one 80, which is already is. Alright, so that's all of our crossovers set now. All of the speakers now muted. Wonderful. So I guess we can move on to the next section. Great. So now we're going to head back to the tune to target and see what's next. Now I'll just turn off that analyzer. Don't need that blinking around in the background. Alright, so back to tune to target. So we've done the routing and we've done our crossovers. So we can tick both of those. And now we need to make sure all of our speakers are properly time aligned. So for that, I need to jump out of the car and set up the microphone at the headrest, because we measured the time alignment with the time alignment clicks using the time alignment tool from outside the vehicle. So let's go do that now. Okay, so here we are out in the garage. We've got the laptop plugged in, the cables running into the cabin, the USB mic positioned at the headrest, got the air conditioning turned off, the volume turned up to a bit over 50%, so everything's kind of set up, ready to go. So let's go do some time alignment. Alright, to do the time alignment, we now want to go into the time alignment tool. So you'll find that under outputs and this sub menu called time alignment. So you just click on that and it'll bring up the time alignment screen. Now you want to make sure that all the groups are first of all set to group X or independent. I'm not sure if this actually makes a difference, but just in case. And you want to make sure all of the delays are set to 0, right? Just quickly run your eye over them all, make sure they're all 0. And okay, we're kind of good to go. So the automatic time measurement tool is down here. You can select it in either delay or distance mode. So this will give you centimeters or inches, and this will give you in milliseconds. Now I like to work in milliseconds, but it's completely up to you. So I'm going to do milliseconds, and so we open up the tool like this, and first of all you'll see a little red screen, a little thing here. So this is me talking, blah 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 blah. Well, actually no, it's not. It's actually the microphone inside the car. So the first thing we want to do before we do anything else is just check that we've got the sound loud enough to be heard, the clicks. So I'm just going to hit the little click sound, and of course we won't hear anything because we've got all of our speakers muted. So I'm just going to stop that for a second, and I'm going to go back and turn all the speakers on. So equalization, just turn all of them on like this. Now I can hear the click going in the background. Excellent. Good. You can kind of hear that going on. So there we go. Back into the time alignment, back into the tool, and let's start that again. And we can see that it's green. So that's good. All right. That means that our levels are high enough. I think on my head unit I've got set to about a little bit past about 60-65% of its maximum volume. Okay. So the first thing we want to do is measure, the first thing we want to do is work out what our reference speaker is going to be. So the way that this tool works is it uses one of the speakers as a reference point that will always play the click, and it'll work out the time of flight through the air from the speaker to the microphone using that one speaker as a reference point. So we first need to go and pick our reference speaker. So I'm a right-hand drive car, so that's going to be my right mid-range speaker, and you can see it on the list here. It's, reference channel right mid-range, right? Here's all your speakers. They're all ticked. And so now I need to go and measure that distance and go and enter it into this little window here. So I'm just going to go do that, and I will be right back. Okay, so that is exactly 106.2 centimeters. So 106.2 centimeters from the center of my speaker grill to the tip of the measurement microphone at the headrest. Okay, so that's good. So that figure has been in now. So now we're ready to basically start the measurement. So all of these speakers are ticked, so we want to measure them all. We've got them all unmuted. We've got our measurement level checked, and it seems to be high enough. So now I can just start the little tick sound, and we're going to hit start. And it should cycle its way through all of the speakers. You can see it working down through the cycling through the speakers, and you can see the impulse measurements down below. Okay, now that's all done, I can turn off the little time measurement click. Now, maybe for some reason you weren't able to get that to work. It threw an error or something like that. Now, the most common reasons for that happening is because the timing click noise is not loud enough. So just turn up the volume on your head unit, or one of the speakers is not properly muted, or something like that, or you haven't got the speakers set up properly in the input-output channels. But otherwise, it should have worked fine. If you have a problem, you can always redo the measurement. You can basically, once you've got all that, you can just hit save data and close, right? This one here. And now all of the delays as measured have ended up in the time alignment tool, right? So here's all the delays here, right? And we had them in delay mode, so oh yes, it has 0.88 milliseconds and so on and so forth. Alright, so now that we've done that, we can go back into the EQ section, and I think we're going to move on to, let's have a quick look. Tune to target, we've done the routing, we've done the crossovers, we've just done the time alignment. So now we need to do the polarity of the speakers. So let's move on to that next. Okay, well, doing polarity of speakers is a little tricky. It's often something people find difficult to do. Now, I have a tutorial on speaker polarity setting. I'll leave the link below, but I'll run through it quickly with you guys. But the best way that I find to do speaker polarity checking, particularly when you're doing pairs, is just by ear using correlated pink noise. But let me explain why correlated pink noise and what to listen for when you're doing your polarity checks. Alright, so polarity checks by ear, what you do is you sit with your head basically between the headrests. You play a pair of speakers together, so let's say the two tweeters, or the two mids, or the two mid bass. And then on one of the speakers, you will flick the polarity from normal to inverted, and you will listen to how the pink noise sound changes. Now, there'll be pink noise everywhere, but you'll find that the pink noise will be kind of concentrated either in the middle of the dash or towards the pillars. And so that's how you listen for whether it's in polarity or not, because when it's in polarity, the two speakers will be summing up and you'll hear the sound in the middle. When they are out of polarity, they will be cancelling and the sound will be split. And that's why we use correlated pink noise, because correlated pink noise is the same pink noise track coming out of both the left and right speaker. So they will sum up and cancel because they're the same pink noise track. Uncorrelated pink noise is two different pink noise tracks coming out of the left and right speaker, and therefore they don't always sum and cancel out. And that's why uncorrelated pink noise is great for things like doing RTAs and speaker response measurements, but not so good when you're doing things like time alignment and polarity checks. So I'm going to show you how to do that. I'm going to work through my set of speakers here just by ear. Now, I'm recording this with headphones on, so I'm going to have to sort of listen without my headphones on and try to record at the same time. So that might be a bit tricky. So if the sound gets a bit wonky, that's all it is. But I'm going to start with, I've got my correlated pink noise track ready to go. I'm going to start with the tweeters. I've got them both turned on and everything else muted. So let's go take a listen. So we're going to start with the tweeters. We've got them both turned on, and I'm just going to use the left tweeter. It doesn't really matter which one you use. Play the pink noise and see which one. So it definitely sounds more split, more concentrated in the middle there. So that is both speakers on normal polarity. So that's great. So now let's move on to the mids. Turn the tweeters off, turn the mids on, and use the left one again. Let's give that a go. Probably a bit loud. Alright, so with one of those inverted, that definitely sounds better, better centered. So I have inverted on the left mid. Now let's try the mid bass. Sometimes you need to turn the volume up a little bit just to hear it properly. So don't be afraid to give it a bit of a crank. Okay, mid bass. You're going to need to give that a bit of volume. I'm going to use the left mid bass. Alright, it's louder and more in the center. Just with one click you can hear it cancel and you can hear it right down near the floor. That's quite easy to hear. So that means the mid bass can be inverted, so I'm going to do that on the left one and turn off the right one. I'll just double check that. So on the left, it's definitely louder like that. So yeah, it's inverted. Then let's do the rears. So we'll turn off the mid bass, turn on the rears, and let's give it a go. Alright, that's better. It's right in the middle behind me, so that means the rears are normal polarity, so they're fine. So just to flip on the left mid and the left low for the moment. Subwoofers I'm not going to worry about at the moment, they're very difficult to hear. Alright, so that's all set by ear. We've got normal on the tweeters, normal on the rears, and a flip on the mids and on the mid bass. Okay, so let's go do some measurements next, and now that we've got our speaker pairs polarity checked. We need to check to see whether the polarity between the tweeters and the mids and the mid bass whether they're playing together or not. Okay, well, in this next section we're going to be looking at how the different speaker pairs are playing together, right? So the tweeters and the mids and the mids and the mid bass and the mid bass and the subs, because we want for example, the mid range and the mid bass to be working together, not against each other, right? And so to check the polarity between speaker pairs, we're going to look at how they're behaving through the crossover region. So the way this works is if the speakers are in polarity and working together, then we'll get, when we measure for example, the left mid and the right mid bass, they're going to sum up through the crossover region. If they are not working together, we're going to see a cancellation or a dip through the crossover region. So that's what we're going to do next. Now we're going to need correlated pink noise because we are measuring summation and cancellation, so we need correlated pink noise for that. And we're going to use the RTA tool just to do a measurement of our speakers. Now because this is an end-to-end tutorial, I'm going to be measuring all of the speaker pairs. After the first couple, if you sort of got the idea and you want to skip ahead, feel free. Alright, so we're going to get started by having a look at the tweeter pairs and then the tweeters and the mid-range first. Alright, so we head over to the RTA, and once again we're not going to be too fussed about the house curves and things. We're really just looking at the speaker responses and how they're behaving through the crossovers and things like that. So we don't need to worry about all this grey background stuff. Now the first thing we want to do is just check our speaker levels, and so we'll play some correlated pink noise, and of course nothing is playing because I've got it all muted, and I'm going to play both of them together. So we need to turn that up a little bit. Get my measurement microphone up near my head so that we can see it. And we have to hit Start Analyzer, otherwise the tool is not recording anything. That's better. So you can see it's a little bit loud. I'm talking at the moment, but it's a little bit loud, so just turn it back a bit. Now I think I incorrectly said, you see how the little red line is below this zero target line? I think I incorrectly said to you before, oh, just turn the volume up. Well, all that does is push the measurement volume into the red, which is not what we want. So sorry about that, guys. I did say that before. That's not right. What I should have said is just click on this little thing here, and that will offset or raise the measurement level to above the zero line where you want it, without pushing the pink noise into the red. So if I stop talking, you'll see the pink, this is now up, but the pink noise is no longer clipping, right? Okay, great. So yeah, that's how you use that little offset. So sorry about that. I gave you the wrong advice before. Okay, so we're going to first of all just measure the left high, and in fact I probably need to lift that level just a fraction more. There we go, that's a bit better. Now it's up around that zero line. So let's get on with measuring the left tweeter, correlated pink noise. Analyzer's running. I'm going to start the measurement, wave the microphone until the timer hits zero. So here we go. Yes, the left tweeter, thank you. And here we go. Great. Alright, so right click, put that into memory 1, so that's now red. And let's go and change to the next one, which is the right high. Now I'm doing this because I like to have the speaker selected, get into the habit of doing that, but you know, it doesn't really matter because we're not doing EQ work at the moment, but you know. Alright, let's do the next measurement. So this is the Did I say left before? Sorry, it was the left tweeter before, now the right tweeter. So start the pink noise. Correlated pink noise. Start the measurement. Right tweeter, yes. There we go, that's the right hand one done. So stop the analyzer. Alright, so we can see left in red, right in blue. Now we're going to measure both tweeters together, and if they are in polarity and working together, we should see the sum of the two speakers is higher than each of the individual speakers. So let's give that a go now. Start the pink noise. Both speakers playing. Excuse me. Start the analyzer. Good. Measurement's still in the green. Let's start the measurement. Great, so there we go. We can see that the tweeters in fact are in polarity. You can see the red and the blue one, and the white one is the measurement of the two of them playing together, and they are, of course, are summing up. You can see them, here. So that looks great. So that means our tweeters are correct in polarity, so that's awesome. So now, just before we do anything else, I want to check the other speakers. So we're going to do the mid-range next. So we can get rid of these measurements. Actually, no, I'll keep those two for a moment. I'm not going to save this summation. I'll come back to that. I'm going to put the mid-range into measurements 3 and 4. So we're going to start with the left mid and back to the RTA. So let's take a measurement of the left mid-range by itself. Now the analyzer is running. Let's check the levels. That's fine. And let's start the measurement. Left mid-range, yes please. Right, so put the left mid-range into memory slot 3 by right-clicking. Now let's do the next one, which will be the right mid-range. Okay, selected. Oops, wrong button. There we go. Alright, so let's measure that. Right, pop that into number 4. Okay, so turn the analyzer off so it doesn't bother us in the background. So now we have the left and right mid-range. You can see the crossing over here with the tweeters around about 3000 Hertz. That's good. So now I'm going to measure the two together and just see whether the mid-ranges are summing up before we before we start looking at the tweeter and the mid-range pair. So once again, just going to start the pink noise and measure. Great. So once again, we're looking at the white line compared to the green and yellow line, and you can see that okay, here it's not summing up as well, or down at this little bit here, but that's not unusual across the entire span of the mid-range. But yeah, they're summing up. Now, if you had the white line running down here, or dipping down like this, then that would indicate that the speakers are out of polarity. Try flipping them and remeasuring and seeing whether it's better or worse. So that's great news. So the mid-range seems to be summing up as well. Let's go take a look at the mid-bass next. So we want to do the left. Oh, I keep doing that, don't I? So we need the left low. Okay, where are we? So start the pink noise again. And start the measurement. Left low, yes. Right, we'll pop the left low into slot 5. Let's go and do the right one, right mid bass. There we go. Gosh. Start the pink noise. Start the measurement. Yes, please. It's great. Plop it into slot 6. So we now have the pink and blue lines are our mid bass. Let's measure them together. And there we go. So you can see the white line around the mid bass, all summing up. So yeah, that's great. So I'm just going to quickly show you what would happen if they were out of polarity. So let's just go flip the polarity on this right low. Okay, let's just do that. And let me just measure that again, and I will show you what happens. Right, so start the pink noise. It should be pretty obvious, like in the first couple of seconds of starting to do the measurement, right? So here we go. And there you are. You can see the white line is now well under the blue and the pink line, right? It's not summing up well at all. So that's the way to check the polarities of your speaker pairs once you've done it by ear, I should say. So let's put that back before we forget. So that meant we did a pretty good job just setting the polarity by ear. So that's great. So now that we know that and we've confirmed that our speaker pair polarities are fine, we can now start checking the polarity between the mids and the tweeters, for example, and work our way sort of down the speakers, right? So we're going to want to start with I'm going to start with the left tweeter and the left mid. I want to go over here and select that. And once again, we're just going to measure. So the left, if I just turn these off for a moment, because we can turn them on and off, right? Just going to turn these off. So this is the mid bass, and this is the right mid-range and the right tweeter. So we're going to be looking at how these two kind of sum up through this region. So we're going to play them together, and if they're working well together, they will sum up or be pretty damn close through this region. And if they don't, then they're going to cancel out. You'll see it sort of like this white line is going to be under here somewhere, right? Now, with high frequency drivers, because there's so many reflections and things going on, you tend to find that the summation cancellation effect is a lot more subtle than it is with lower frequency drivers where there's less going on. So you tend to find that low frequency drivers, you'll get a typical 6 dB summation when they're perfectly phase aligned. But with mid-range and tweeters, 6 dB is not always possible. 3 dB is more usual in my experience. So yeah, sometimes these cancellation summations are not as strong, just because there's much more going on. Alright, so let's go and do the next measurement now. So the analyzer is already running. Let's start the pink noise. Get my microphone ready. Start the pink noise, and let's take a measurement. Great. So here through the turn the analyzer off. So here we can see through this region here, the white line is definitely above. So that's summing up nicely through the crossovers. So that tells us that the left tweeter and the left mid are in polarity. So that's great. Let's go and do the next one, which will be the right hand side. So just left click on those, left click. And now we're looking at the summation through the blue and the yellow. We're going to want to change these. I technically don't need to do this, but I'm going to do it anyway. Back to the RTA. Oops, that's not right. I'm after the right tweeter. There we go. Okay, so once again, let's just measure this pair. And great, look. Nope, turn the analyzer off. So there we go. We've got summation through that crossover region, so fabulous. So that's the tweeters and the mids confirmed. Now we're going to move on to the mid-range and the mid-bass. Alright, so we can turn off the tweeter, and we'll start with the left mid and the left mid-bass. And just check that we've got the polarities correct, so inverted and normal, inverted and normal. Okay, that's the way that we had them before. And so we're going to go into the RTA, and this time we're going to want measurements 3 and measurement 5, so this green and this pink one. And we're going to start the pink noise, start the analyzer, get our microphone ready, start the measurement. No, that is not the one we want. Not the one we want. We actually want the left mid-range. Okay, that's better. Let's try that again. So, pink noise on, start measurement. Okay, well, turn the analyzer off again. Go there, it's gone. Right, so let's have a look at this white line, and you can see that it's not summing up as expected through the crossover region. It's actually dipping down below the green line here. It's well down below the crossover here, and it's dipping down here, which would indicate that these speakers are out of polarity. So what I'm going to do is flip. Now we know the mid and the tweeter are in polarity. They were summing up to the crossover, so I need to flip the polarity on the left mid bass. So let's go do that now. So the left mid bass, this one here. Let's flip the polarity, and I've got to do the same on the other one, otherwise I'm going to throw them out. So now I've got the polarity normal on the left low and polarity flipped on the right low. And let's take another measurement. All the speakers are already kind of set up. Start the analyzer. Pink noise. Where are you, my pink noise? There we are. Let's take another measurement. And there we go, look at that. Now we've got it summing up through the crossover region. So that means they're now in polarity, which means that the mid-bass needed to reverse the polarity because they were working against the mid-range. Now they're working together just fine. So that means we could move on to the right pair, the right mid and the right mid-bass. So let's get that set up now. Right mid, turn that one on and the other one's off. Fantastic. In the RTA, now we're going to need measurements 4 and 6. Lovely. Alright, so now that this has been flipped, it should work. And we should see summation through that crossover. Start the analyzer, start the pink noise. Start the measurement. And look at that. Stop the analyzer. There we go. Look at that, summing up through that crossover beautifully. Alright, so that means the tweeters, the mid-range and the mid-bass are all working together. They're all in the right polarity. So now we need to do the mid-bass and the subwoofers. So let's move on to that next. Alright, so we have the tweeters, the mid-range and the mid-bass all polarity checked. So from here on in, we don't want to flip the polarities on any of these speakers. We really just want to play around with the polarities on the subwoofers. Now, the subwoofers are going to have so much more level than the front end because we haven't level matched things, and that usually happens in the tune to target tool. But we're just doing polarity match checking, so we can drop the subwoofer levels if we need to, and I suspect that we will need to. But let's find out. So first of all, we need to measure both the left and right mid-bass playing together as a pair, and then we'll play both mid-bass with the subwoofers to give it the best chance of having an influence on each other, right? Because, yeah, you'll see what I mean. Okay, so let's head over to the RTA. Let's take our first measurement, which will be the mid-bass pair. So we want the pink noise and the mid-bass pair is selected, and let's give this a go. Okay, that's that pair done. Let's just save that, right click, save it into measurement 7. Alright, so that's the mid-bass pair. Now we're going to measure the front sub. Let's see, front sub, that's one here. Polarity normal, okay. And the rear sub is also polarity normal. Okay, great. Well, let's measure the rear sub first. And it's going to be pretty loud, folks. Great, that's the rear sub. Let's put that into measurement 8. Yeah, we'll see how we go. And then let's measure the front sub. Fabulous. So put that into measurement 9. And yeah, there we go. Got all of those measurements ready. Now, most people won't have a front sub and a rear sub, but it kind of works the same way anyway. So first of all, we're going to have to time align the mid-bass to one of the subs, and then sorry, not time align, check the polarity of one of the subs against the mid-bass, and then check the polarity of the sub against the other sub. Now, because my front sub is sort of part of the front stage, with the mid bass, I'm going to try to check the polarity of the mid bass versus the front sub, but if this was your only sub, you would do it exactly the same way. Like we could pretend that we don't have a rear sub, right? But let's do that. So I'm going to get rid of, what measurement is it, number 8? Right, so front sub versus the mid bass. So I want to, I always like to do it in the RTA section. I want those two, so the the front subs, that's better, and the two mid bass. Alright, let's give this a go. Alrighty, so start the analyzer, start the pink noise, hit measurement, yes. And let's just put that into measurement 3, because we don't need those other ones anymore. And just turn that off. Let's have a little look. So we're looking at the green line versus the grey and the blue, and you would expect that doesn't look like it's in polarity, because you'd expect it to sum up, through this crossover region, which is right here. So let's do a polarity flip on the sub and see what we get. Alright, so start the analyzer. Yep, there we go. And let's put that into memory slot 4. Get rid of that one. And there you go. Exactly what we expect. It's following the mid-bass grey line, summing up through the crossover, and then doing that. So that means that the front subwoofer needs to have its polarity inverted. Now, if you just had one subwoofer, that's where you would stop. That would mean all of your speaker polarity have been checked and everything's happy days. But because I have a rear subwoofer as well, I have one more step, which is to check the polarity between the front and the rear subwoofer, right? So to do that, we can get rid of the mid bass, so I can turn off measurement 7, and I can turn off actually this measurement as well. And M9 is the front sub, and M8 was the rear sub from memory. Okay. Alright, so this is going to be a little tricky because there isn't, it's crossing over here somewhere. That's where they're around about that 50 hertz mark. But what we'll be looking for is when we play them together, one will be better than the other. Okay. Now we've got the polarity set on the front sub to match everything else. So this time we're going to want to be setting or checking the polarity. If we need to flip it, it'll be flipped on the front subwoofer, right? Because we don't want to change these now. These are all sort of all plugged in. All right. So let me just get rid of that white line. Okay. All right. So here's our in the analyzer for a second. So what we'd be looking for is some sort of summation that kind of sums up through, particularly where these two speakers are playing together through this area. One will be better than the other. Alright, so let's just turn on the subs and let's do a measurement. Start the analyzer, start the pink noise, hit start, start measurement. Okay, so let's see what we've got. Yeah, it's not. Yeah, it's hard to say. Let's flip the polarity and see what we get with the second measurement. Polarity flipped. RTA. Start the analyzer. Check, check. There we are. Alright, it's a little bit difficult to see. I should have probably saved the other measurement. So I'm going to save that measurement to, let's try something with a different color, M4. Alright, so it's nice and yellow. I'll have to go back and flip it back and redo it because I didn't save that measurement before. Okay. Try again. Sorry, folks. Okay, that's better. So let's just turn off that one and that one. So we're now just looking at the comparison. So the yellow one was where we had the polarity flip. The white one is the measurement that we just took. And through the crossover region here, you see the white one kind of wins, right? That's where they're kind of interacting. Now, I would have expected them to kind of follow this blue line a bit. So it indicates to me that the subs aren't perfectly timed. But we're just using the software as it is. So if I was to make a choice between these two, I would probably go with, well, there's not much in it, is there? I mean, it's sort of cancelling out through here. That's that one and that one. Oh, not that one. M9, that's better. So it's sort of cancelling out at very low frequencies. It's summing up through there, but it's mainly being driven by the rear sub. And through the crossover region, neither of them are really summing. I mean, the white one's summing up a bit better than the yellow one. And then through the crossover region here, the white one is summing up, the yellow one is cancelling out slightly, which is kind of, the influence of this slope here. So for me, it feels like the last measurement we did is just a touch better through most of the response, and so I'm going to go with that. So that means that this rear subwoofer will have a normal polarity, the front subwoofer will have an inverted polarity, and yeah, everything else is as we checked it. So There you go. We now have all the speaker polarities set, checked and verified, and now we're ready to move on to the next step. Alright, with all of that done, we're now ready to move on and do the rest of our tune using the Tune to Target tool. So we find that down here under the RTA tab, click Tune to Target, and this is the welcome screen. Basically, well, before I go on, I better explain a couple of things about the tool itself. So first of all, I'm using a beta version of the tool. That means it's still in development, and the Audio Tech Fisher guys are still making improvements and things to it. So depending on when you're watching this video, it may look a little bit different to how I show it in the demonstration. The second thing is the tool is basically will provide you a base level daily tune. It's not going to deliver you a competition level SQ professional tune or something like that. It just it's not intended for that. It will give you something that you can then tweak around to suit your own personal style. So just have realistic expectations of what you can get out of this. But I've heard the end result and it sounds pretty good to me. So yeah. I think the Audio Tech Fisher guys have done a fabulous job in providing a lot of instruction and showing you what to do step by step, both in the tool itself and also in the help menu. So you can click over here in help and click on Tune to Target, and it'll give you all the information about the tool and the step-by-step process to use. Yeah, and of course down here, it talks about expected results, well-optimized baseline. Will give you a solid foundation, but expert tuning is required for the best experience. So yeah, just sort of covering off that again. Alright, so let's get on with the demonstration. So first of all, before you can use the Tune to Target tool, it has a bunch of prerequisites. And the first half of this tutorial is all about how to complete your tune so that you are ready to use the Tune to Target tool. So we have set up all the input outputs and correctly named all the channels. We've put in all of our crossovers using Linkwitz-Riley 24 dB slopes, and made sure that we have matching frequencies on the left and right speakers, so we can tick both of those. We've done our time alignment, we have checked and validated our polarities, and we've got our microphone measurement microphone set up. So that's all done, so I can click on that, and yeah, we're ready to go. Alright, so the next screen you will get is almost like a setup screen, so you can customize the tune that you want to do. So I'll just work from the top down to the bottom. So the first one is general config, so whether you want the tune to act on your output channels or your output channels and your virtual channels. Now, I'm not going to bother with my virtual channels because they're basically just left and right, but if you've got something a little more complicated, then maybe you want the Tune to Target tool to EQ your virtual channels as well. Really up to you. The next is how much time, measurement time that you're going to take when EQing each channel. The default is set to 10 seconds. That seems fine to me. Then there is the resolution. Now this is set to 1.6 because I'm in beginner mode. I'm going to go back to welcome and I'm going to change this to advanced mode. And back into here. Okay, now I can change the resolution. So 1.6 is the default. 1.6 is fine, that's what I use. But you want to have more resolution, you can try 1/12 or 1/24. Feel free to have a play around with that. Then we have channel gain configuration. So what the Tune to Target tool will do is it basically will EQ your speakers and also level match your speakers so that they are tonally balanced across the tune. Now this little checkbox basically says if you want the tool to do both, then tick this little checkbox to say you want to normalize the gain across your output channels. If you don't want that to happen, you don't want the tool to do your level matching for you, and you just want it to do EQ, just make sure that that is unticked. Then there are these things called predefined gain levels for different types. So normally you wouldn't want your rear speakers to be as loud as your front speakers. So you might put a small cut, of 3 or 4 or 5 dB on your rear speakers. Sometimes you want your center speaker to be a little louder than your left and right speakers, so you might put a couple of dB gain, or you can change the gain on your subwoofers. I'm just going to leave these all at default. I'm not running a centered channel, and I'm not going to get the system to EQ my rear channels or anything like that. I'm going to leave them out of this demonstration. But you can play around with this as well if you like. The next one is your house curve for your tune. Now there's only 2 options really available. You can run a flat tune, but I wouldn't recommend it. It's really the Audio-Tech Fisher Daily or the Audio-Tech Fisher SQ. I'm going to just do a demonstration on the daily tune, and you just tick whether you have a subwoofer or not, right? Or you want the house curve to include the subwoofer, which I do. Then there's the frequency range that it's going to do its EQ work over, 20 Hertz to 18,000. That's you can change that around. And then we're ready to sort of move on to the next page. Alright, so here are all your speakers, and there's a couple of things you can do on this page. You can select which speakers you want to include in the tuning run. Now I'm going to turn off my rear speakers, right? I'm not going to include them. I just want my front stage and subwoofers to be included in the demo. And in here you can add some gain offsets. So for example, if your subwoofers are a bit loud and you want to cut them back a little bit, you can change the gain settings in here. But for the demo, I'm just going to leave them all at 0. Okay, so on to the next screen, and this is probably the most important and also the trickiest screen to get right. Essentially, this is the system figuring out whether your measurement level is set high enough, or not too high and not too low, for it to do an accurate measurement and do an accurate EQ and level match. Now you'll notice that this bar over here has a little black line. So this is kind of your level meter. It's going up and down because I'm talking, and and the level is changing. But the whole aim of getting this right, or being able to move on to the next stage, I should say, is you want all of these to be green, right? Or come up with a tick next to them, for want of a better term. Now, this is dependent upon a couple of things. First of all, the volume setting that you've got your test track being played at, right? So we're going to be playing uncorrelated pink noise. We're going to be holding the microphone, near our listening position. You can wave it around or just hold it near your nose. We're only checking levels at this stage. And what's going to happen is, what I suggest you do is set your, let's say you're using a head unit or your conductor or something to set your volume level for your pink noise. Set it at about half volume, 50% volume, maybe 60% of volume or something like that. And then when we click this button here, it's going, we're going to start the pink noise, we're going to hold our microphone in position, and then we're going to hit this button called Reset Channels and start level measurement. Now, what this is going to do is, in your DSP, if you've got any speaker gains set at all, it's going to set them back to 0. Okay? And so you want to find a output level where your subs all the way through to your tweeters are all in the green zone. And often your subs will trip it and make it go red. Okay, that's the problem because they've got so much more energy than your other speakers. But you're trying to find that balance where all of these speakers register in this green zone. Now, if you're having trouble doing that and you're doing a run of this and it doesn't work and it comes up red and it says, your speakers are too loud or too soft or whatever, just adjust your volume knob, one click one direction and run the system again, or one click in the other direction, run the system again, and you should find a setting on your volume knob that gives you a green output like this, right? So let me do a run. Now it's going to get pretty loud in here because well, first of all, if you don't hear anything when you hit this button, it's because you've got all your speakers muted, right? So we need to go into here and turn on all your speakers, right? Don't forget to do that. So I've got my subwoofers. I'm going to leave my rear speakers off. I don't need them. Okay, so now I can go back into the tool. Here we are. Alright, so as I said, it's going to get pretty loud. I'm holding my microphone up near the listening position, and here we go. Alright, so you saw how that one stayed red. So that means now I had it turned up deliberately too loud to show you that error. So what I'm going to do is now reduce the volume down a little bit and rerun it. Okay, ready? We're going to do that again. Once again, it's going to get pretty loud. I'm going to play the pink noise. My microphone's up near the listening position. Alright, this time they all turn green. Now, if for some reason you're having problems and that's not working for you, the other thing it could be is your microphone sensitivity. So there's some notes up here about that, particularly on Win 11, where you might need to turn off your noise reduction or change your microphone level settings. Now, or you might find that you haven't got your microphone set up properly, right, if something's not working. So a couple of things to check. First of all, we can go here to this button, and this will take you to the audio input setup of the DSP. Just make sure that your measurement microphone is properly selected here. Okay. So back to the tune to target. The second thing it might be is your microphone gain. So you can click this one. This will open your Windows sound setting. You want to find your microphone and make sure it's selected, your measurement microphone. And then under device properties, I think it is, yeah. Here's your microphone gain. Now, when I had this set at 100%, I was having trouble getting those levels to match. So I had to drop it back, in this case, to 81%. But it seems to work with the microphone gain turned down a little bit. Okay, so we can go back there. Alright, so with my head unit set at a little fraction over half volume, my microphone gain turned down to 81. All of my speakers are kind of ready to go. Everything's green, so I can now move on to the next stage. Alright, so this is the actual measurement stage where the Tune to Target tool is going to cycle through, first of all your left speakers, then all your right speakers, and then your subwoofers, right? So the way it's going to work is you're going to be wanting to play uncorrelated pink noise all the way through the measurement process, and you're going to be wanting to wave, or you're going to wave the microphone, from ear to ear, as you'll see in the little illustration, right? I'm just going to lift this up just a fraction. Okay, so down here are some little buttons and things. The first one here is start delay. Now, it's set by default at 5 seconds. What that means is between speakers there'll be a 5-second delay. Now that's a little long for me, so I just set it to 2. Now the very first speaker measurement is always 5 seconds, but after that, between, for example, your left low and your right high, there's going to be a 2-second delay, which means that you can reset your uncorrelated pink noise if you're getting towards the end of the track or something like that. Okay, so what we're going to do is hit the start the pink noise playing. You're going to hit start measurement. You're going to wave the microphone around, and you'll see down here where it says 0 seconds, there'll be a countdown, right? And so you want to wave the microphone around till the countdown's done, and hopefully it'll pop up and say something like, oh yeah, no, little green line, and it looks like it worked. If it pops up with a little window, then I'll explain what to do. And in fact, I'm going to turn up the volume a little bit just to show you what happens if you get an error. All right, so here I'm going to do the first measurement. So pink noise. Right, so it's now measuring the left high. Waiting for the countdown to hit 0. And okay, turn off the pink noise. So if you get this error, it says that the measurement level was too low. Now it says here maximum level 0 dB. In fact, what I did is I turned the volume level up. So I'm guessing that what it's done is it's clipped or something. So I'm going to turn the volume level back to 50%, where it was when I was doing the level matching. I just want to show what happens when you get one of these errors. Now you can ignore this warning and just hit accept. You can skip the channel. You can just get out of tune to target and start all over again. Or in this case, I'm just going to hit I'm going to adjust the volume level back a little bit, and I'm going to hit retry measurement. Okay, so it's going to take me back, and I'm going to start the pink noise again. And with the volume turned down a little bit now, it should work. There we go. Now it's moved on to the left mid-range. That worked as well. Now the left mid-bass. So once again, if you get one of those error boxes pop up, just one click on the volume up or down, rerun it, see if it works. Right, that one worked. But if you do change the volume level, you have to sort of start from the very beginning. Okay, that one worked. If you do change the volume level, just go right back to the very start and remeasure all your speakers, because the tune to target uses all these measures to set your level gain. So if you change your volume halfway through, your gains, like your level matching, is not going to work. Okay, that's great. Now it's doing the right mid bass. You can see how many bands of EQ it's used and how accurate it was in terms of deviation. Great. Now the sub, rear sub. This is often where you'll have problems because the sub will often trip, the maximum measurement volume. And so there we are. Now the trickiest part, as I said, is getting through that whole series without it tripping one of the measurement level limits, and it's usually the subwoofers that will tip you over. So it's a balancing act, and keep adjusting your volume level on your knob till you find the right setting on your volume level that lets you get through all the speakers. If you do adjust your volume level, go back to the start, do it again. Otherwise your level matching won't work. Yeah, so that's how the system runs through all of your speakers. If you're still having trouble, once again, have a play around with your microphone gains. They might be set up a little too high. Okay, so now you have some options. One is to start the tune all over again. One is to just restart all of your measures if you need to play around with your volume. And then if you're all done and you've got through that all unscathed, then you can just click Apply Settings and Close. Now, once that happens and you go back into your DSP, you should find that the EQ and your levels have all been applied to your channels, right? There you go. So yeah, how about that? Seems to have worked pretty well. Now I'm going to have a listen to how the tune turned out. I will record it and release it as a separate little demonstration video. So yeah, I hope you found that interesting, guys. Good luck, and let me know how you go with your own tune to target adventures. So there you go, guys. That brings us to the end of today's tutorial. I hope you found that interesting. As always, if you've got any questions, please feel free to throw them down below. I'll try to get to them as soon as I possibly can. Otherwise, thank you so much for watching, and I will catch you in the next episode.